Hi, welcome back. Now we're going to learn about chain rule because I know you have questions like, okay, fine, the derivative of sine x is cosine x. How about the derivative of sine 2x? Well, let's see. Let's start with that. Let's say y equals sine of 2x. How about the derivative? Well, this is going to be, yes, cosine 2x because the derivative of sine is cosine, and I'm going to copy paste whatever I have in here, but actually 2x is a function, right? So that must also be differentiated, which we do, and we write the derivative of that function in the front, like, well, 2x's derivative is 2, so it's going to be 2 cosine 2x. So this is how we apply what is called as chain rule. We first differentiate the actual function, sine becomes cosine in the derivative, and then we differentiate the function in this function, and it becomes 2 in this case. So we write the derivative of that function here in front, so it becomes, well, sine 2x is cosine 2x, fine, but it is 2 cosine 2x because we have the derivative of this function 2x as well. Another example, we have y equals cosine 5x, and its derivative will be 5 times minus sine 5x. Of course, this doesn't look nice, so we have to write this as minus 5 sine 5x. So the derivative is cosine is sine, that's what I did, and I copied the function here. That doesn't change. But then the function's derivative is 5, and I write it there. So it becomes minus 5 sine 5x. So when it comes to chain rule, one of the applications of chain rule is that if we have two functions and we write them as composite functions, then their derivative will be that first we're going to take the derivative of the function inside and then the derivative of the other function. So we write the derivatives of both functions. That's what happens in these examples. We have two functions here in this example. For example, we have f of x being sine x and g of x being 2x, and we write f g of x saying this is going to be sine of 2x, right? Wherever you see x, you write g of x, and you end up with this. And this is how we express the derivative of such composite functions. Let's see a few more examples. So for the first one, when I start writing dy over dx, I'll copy paste the 3, and then I'm going to write the derivative of this. Well, it's going to be 1 over 3, right? The derivative of 1 over 3x is 1 over 3. And then derivative of sine is cosine, and I copy paste the function here, 1 over 3x. So that is the derivative, which needs some manipulation, right? So I will simplify these and write this is cosine 1 over 3x. For the second one, well, we know that the derivative of e to the power of x is e to the power of x. That is not going to change, but of course I have to take the derivative of this function here. So it's going to be 3 times e to the power of 3x, and derivative of 1 is 0, so I don't need to write this down. And for the third one, this is slightly different. Let's look at this. In natural logarithms, we have to apply the laws of logarithms. So first of all, I have to rewrite this function as, this is going to be 3 times ln x, because I can write the power as coefficient. And for 7x, I'm going to write it like ln 7 plus ln x, because if there's multiplication here, I can write them as separate logarithmic expressions in addition. And you can also see that there are 3 ln x here and 1 here, so I can simplify this further to 4 ln x plus ln 7. Well, obviously, ln 7 is a number, like 1 here, so the derivative of that will be 0. And for 4 ln x, it is going to be, let's write the derivative, it is going to be 4 times ln x's derivative is 1 over x. So basically, without even writing this, you can write 4 over x. At this point, I want to make a small parenthesis and show you what happens when we have a function like 2 to the power of 3x. Now let's find the derivative of this. Well, what happens is the derivative of any number to the power of x is as in e to the power of x, any number to the power of x again, but multiplied by ln a. Actually, this is the case for e to the x as well. The derivative is e to the x times ln e. But just because this number is 1, we don't write this down. We just say it's e to the power of x. So, in this case, when we have 2 to the power of 3x, we're going to write the derivative as like this. We have to, of course, take the derivative of 3x first. So it's going to be, let's write dy over dx. It is going to be 3 times 2 to the power of 3x. So far, so good. And then I'm going to write the base with the natural logarithm, which is ln 2. So this is what happens if you have an exponential function with the base different than e. Right, let's look at this example now. Let's say we have y equals e to the power of sine x. Ooh, now let's write this derivative. It's easy. I'm going to take the derivative of sine x, which is cosine x, and the derivative of e is the same, so it's going to be e to the power of sine x. So what I'm trying to show here is that if you stick to the rules, you're going to find the right answer. Don't get intimidated by the functions given. Another example, y equals tangent 7x. Well, the derivative of tangent is secant squared. So I'm going to write first the derivative of 7x, which is 7, and then secant squared 7x. Make sure that you just write the same function here. That is the most common mistake done, because you take the derivative of 7x, you write 7, you think that 7 goes away from here, which it doesn't. So don't write 7 secant squared x here, because that is not correct. The function here is 7x, so it must be 7x appearing here. Now let's look at this example. Let's say y equals, in brackets, 3x to the power of 4 plus x to the power of 5. Now we have two functions here, if you can see. I mean, this is a function in itself, and it's also whatever is inside to the power of 5. So we have to apply two rules here. So let me write dy over dx, and let's discuss how I wrote this expression. So first of all, I'm going to write 5 times 3x to the power of 4 plus x to the power of 4. And then I'm going to write down 12x cubed plus 1 in brackets. So what did I just do? First, I treated this as a single unknown. So I said, let's say this is u to the power of 5. So the derivative must be 5u to the power of 4. This is what I did in here. And then I wrote the derivative of the function inside and all of these in multiplication. If this is confusing, you can just say that let u is 3x to the power of 4 plus x. Then du over dx will be 12x cubed plus 1, right? This is the derivative of the function u. But just because you said u is this, then y becomes u to the power of 5, right? You wrote u instead of this expression. So what is the derivative of this? So dy, in terms of du, of course, it's going to be 5 times u to the power of 4. So basically, I'm going to now rewrite all these into this chain rule formula, which is dy over dx equals dy over du times du over dx. You can see the basic algebra here. Du simplify, and you end up with dy over dx, right? But what happens here is, first I'm going to write dy over du. Of course, I'm not going to use u here. I'm going to write 5 times what u is. It is this expression, 3x to the 4 plus x times du over dx, which is the derivative of that. So it is 12x cubed plus 1. So either you directly write the derivative, or you can use substitution to end up with the derivative of such functions. Let's see another example. So let's find the derivative of sine cubed x. Well, if I directly try to write this, I'm going to first deal with the power. It's going to be 3 times sine squared x, right? And then I'm going to take the derivative of the sine x function itself. So it's going to be cosine x. That's what I'm going to write for the derivative of sine cubed x. Right, let's look at this one. We have y equals square root of 5x squared plus 1. Well, it would help if you write y equals 5x squared plus 1 to the power of 1 over 2, because then you're going to deal with the power first. So it's going to be 1 over 2 times whatever is inside. I copy paste, and then taking away 1, it's going to be minus 1 over 2 as a power. And then I'm going to deal with what is inside. I'm going to write times, well, 5x squared plus 1 will end up as 10x as a derivative. So what we do is, first we deal with this being something simple like u, right? So it's u to the power of 1 over 2, and I take the derivative of it, and then I deal with whatever is inside. So that's pretty much it about the chain rule. It seems complicated, but actually it's easy once you practice. So it's time for practice. Thanks for watching.